Good afternoon to all of you. Welcome back to this second lecture of module of GIS. Today I will be speaking on geographical phenomena and its GIS link. It is basically converting information what is there on the ground and bringing into the GIS environment. And then how to bring and what are the processes are involved in between, and then how these different features are divided into, like whatever is there on the ground. So that ground information, either it is something what you look at it, or some activity, or the process are involved. All those things, how to convert into a GIS environment and finally bring into the visualization. So those are the issues I will be discussing during my talk. So when you talk about a geographical phenomena, it is something like it refers to a process or an activity or existence in the real world. So example is something like when you take a picture from the satellite, you get a picture giving the information about the ground. So that means it is a instant information of a particular area for a particular time and period. So that information is called, something is existing on the ground, and then how that information you can bring into the GIS. So activity is something is happening. Suppose if you are talk about a suppose you have to prepare a land use land cover map. So that is the activity. For that activity, what is the process is involved? Suppose for generation of a land use land cover map, what we do, what are the things are required for that? So then first you should also understand for whom we are making that land use land cover map, and then what is the requirement for that purpose. Is it a city high resolution map that is required, or it is a agriculture area you require, or a forest area you require? According to your requirement, you also choose type of the product from which you can extract the information. If somebody wanted to know the general information about overall land use land cover, for that probably you can also use a topographic map which is generated way back this thing. But in a city, if you wanted to generate a land use land cover map and then try to plan for a developmental activities, so probably you may require the satellite image of the latest date, so that you know that what are the already developments have taken place and how we can plan for the future development based on the present scenario. So for that, maybe you require a high resolution data, and then you should also know that how to convert that data into different land use land cover. Either you will adopt digital method, automatic method of converting that satellite image, or you use manual method of converting, or you use a computer monitor and online on-screen digitization, etc. So once you decide on that, so then you have to design the process. What are the processes involved? Process involving like taking a satellite data, and then that you have to do the registration, and from registration to after that you convert into useful information, either automatic method, semi-automatic method, or manual method. So then you convert into land use land cover map. So these are all things, whatever is there on the ground, what is existing, that you straight away take it. Another is if you want to do activity, what are the processes are involved to convert that into an useful information. So you can also say that anything meaningful on the earth, what you wanted to convert, so that is called a geographical phenomena. So next, if you see that example, the images, what you see, so there is a cyclonic storm here, and there is the mountain where the smoke is coming, it is because of magma activity, and then smoke is coming from that, and then people are sitting here watching this. So, and then the activity is horses running in the snow areas. If you talk about people sitting and watching, you can see, you can say it is something like a what is existing on there. And then if you talk about a here smoke is coming, it is activity is going on, and then this is also you have a cyclonic storm, which is activity, and then your which is having something is happening. Another is which is there as it is. All this information how you should bring into your GIS environment. So that is the main purpose of this lecture. So if you see this again, there is one more example. This is mountains, and then there is a lake in between that, and then this is as you see from the ground. But suppose if you wanted to see from the satellite, it is that is a more of a planimetric view where you know exact area of each thing, how much area is covering of all those things, and then how to represent in a computer, and finally to GIS. So that we will discuss further. So basically what happens is in case of this is somebody sitting here, bear is sitting here, and then there somebody is doing an art of that. See what will happen here is according to the artistic this thing, his own skills, and then his own requirement, and then his own purpose to whom he wanted to or she wanted to present. So accordingly this picture is converted here. So as far as GIS is concerned, so this type of thing, misrepresentation is not correct for us. So for that, what normally we have to will think of it, whatever is the ground, we will take a decision to standardize how to convert what is there on the ground. So for that we have to bring out some standards, and then the representation, what representation you wanted to do that. So one earlier yesterday also we are talking about a vector representation and a raster representation. So then the standards are important component, and then but in case of the artist, so it is more of a artistic representation where the people do according to their own requirement. If you see here, the same thing, three different people are sitting, seeing the environment. So here what is doing? The artist is doing what is looking in front of him, and then he may give emphasis what has to be highlighted. And then in case of a story writer, so he will try to convert that information in terms of a textual information. So another is how to capture this, the photographer or the person with a video camera or whatever, he will capture the information according to the requirement. So for the purpose for which he is making it. So that means for whatever is existing on the ground, so there it is there as it is, but there are three different people with a three different type of objectives collecting the information, and then that information is again used for different purposes. In case of a GIS, so we should have a uniformity of a framework, and then you define each thing, how much of each area I have to take. So I cannot here say some of the area I cannot highlight, some of the area I cannot reduce or eliminate. We have to show as it is, how it is existing on the ground. So something like when you get a satellite data, you will get a real picture of that, and then whatever you get in that, you basically convert into into an information. Like yesterday I was also mentioning, what is it comes in a digital numbers, those things we convert into your useful information in terms of the features what exist on the ground. So our ultimate aim is whatever is that geographic phenomena what is there on the ground, so using the computer with the representations, and then you finally bring into the is a map or a satellite image, or in terms of a three-dimensional, you can also do use for visualization and reference and decision making. All these things will depend upon the how you actually converted your information into a computer in terms of a different data models like a raster model, vector model, etc. And then finally bring into in terms of a visualization for decision making and then for further analysis. So the purpose is the geographical phenomena, what is there on the ground, bring into the computer, and how do you do that, and then finally use it for different application, either for visualization, either for analysis, and then for further maybe for the decision making purposes. So these are the steps involved. We'll go one by one, starting with the geographical phenomena. So what is that? Geography is a something of interest that can be named or described. Suppose what is there on the ground. So like a suppose there is a writer is there, he is getting the information from that. So or there is a water body is there. So how to you give attributes to that what is there on the ground. So that those can be named and described. So that is getting the answer for what it is, and then can that be a georeferenced, and then to a particular location. So the georeferencing is very important, as I mentioned yesterday also. So georeferencing is referring that into the actually what is there on the ground, and then to the particular location where it is there, and then giving the latitude, longitude to that, and then so later on if something changes are happening, we can see that what are the changes happening to that same particular location. So it is something like answering where information through the georeferencing can be assigned a time at which it was present. So suppose there is a water body, so it was there maybe 10 to 20 years back, but now it is not there. So like there is snow covered area, but it was there maybe 50 years back, but there is no snow cover now. So there to find the changes, so the time component is also very important. That is when we are bringing into the when into that. So what if one of them is missing? So what will happen to this thing? In a GIS, normally if you make a layer, what describing that each feature, that normally we give that information, and then where it is located, once you georeference it, the location information also comes. These two information normally covered, but the time component if you wanted to incorporate, so then you should have the information in a dynamic nature. So say something is there at a particular location and then at a particular time. So maybe it is changing. Suppose you talk about a cyclonic storm, and then it is starting at somewhere deep inside the sea, but slowly it moves and it comes to the hitting the shore. So that means that there is a something phenomena, it is moving and then coming. So that all this dynamic information can bring into the GIS. So that is what answering the time component there. So most of these things normally what we do is, instead of bringing this dynamic nature, what we can do, you can make the series of informed layers, so that if we combine all together, so this dynamic thing can be brought into that. If you see that different types of geographical phenomena, we see different this thing. There are two types of geographical phenomena. They can be broadly classified into man-made things and natural things. So man-made things, something like you construct buildings and you construct reservoirs, and then you make cropping areas. So these are all man-made things. And then you have a natural things. So natural vegetation, and then the terrain is there. So the terrain is coming because naturally it is happening, because the mountains are also created naturally, and the terrain information is created. And then if you talk about this man-made thing and the natural things, so there also can be divided into two. See, one is something is continuous, another is a discrete. Continuous means it happens in a continuous manner, and then there are no empty spaces in between. So if you talk about the mountainous terrain, and then if you go on that, so there is no breaks. The mountain is going up and down, and then the slope is changing, height is changing, but the height is happening at every place. So height may be here 600 meters, next 601 meter, like that it happens. And then another thing is, if you wanted to represent a temperature or a precipitation or or a area, at every place you will have a temperature. Maybe the value is changing, but it is continuous. The temperature is something is here maybe 25 degrees, and next is 25.2 or whatever it is. The temperature varies according to the condition of the local area, and then according to the height of that terrain, the temperature also varies, but it is continuous. So something is discrete is, suppose you talk about land use land cover map, you make the boundaries along the land use land cover map. So this is agriculture field. Inside the agriculture field, there is a sugar cane is there, rice field is there, wheat is there. So all these things, you put a boundary for those things, and then these fields are more of a discrete. That means up to certain extent you find a rice field, and after that certain extent you also find a sugar cane field. So that means there is a boundary which is separating two things. So these are all called discrete things. And then one more thing you should understand is field and object. So there are two things when you talk about a geographical phenomena. So one is called a field. So field is a geographic phenomena for which every point in the study area, a value can be determined. So like a continuous feature is, we can also say it is a field. So if you create the temperature map or a barometric pressure and elevation map, so then what we are doing is we are putting the value for each area. There is no break in between. Suppose there is a height value is there at a particular location, and if you go to the next place, there will be also certain height. There will not be any vacuum in between that. So this field is a something on the study area which can be determined, something like a temperature, barometric pressure, elevation, etc. Another is an object. Object is something like a building is there, or the temple is there. So these are all the different type of object existing on the area. The object is usually a well distinguishable, discrete, bounded entity. So the space between objects are potentially empty. Suppose if you see moving inside a city, so then you have there is a building, commercial building, residential building, and then the school is there, and then there is a park. So everything are there, different type of urban features. But at the same time, if you see in between these urban features like buildings, you will find spaces in between that. So those are all called objects. In case of what I said earlier, it is a continuous phenomena. There is no gap in between there, and everywhere, every point, if you go there, so there is something is available. If it is a height, this thing, there is a elevation map. If it is talking about the temperature, you find a different temperature there. In case of the object, so they are well distinguishable entity, discrete and bounded entity. The space between them are potentially empty. So these are the two different things. Important thing you should be able to understand. So later on, they are useful further to understand what is geographical phenomena, how it can be used for the GIS. So field is most of the time is natural. Object in most of the time is a man-made. So if you talk about buildings and schools, temples, so there are well distinguishable and then objects bounded entity. But the thing is, they are mostly man-made. In case of field, it is most of the time is natural. Suppose if you talk about elevation, temperature, pressure, and then slope, etc. So they are comes under a field. So after going through that, this thing, something like field and an object, and then continuous and discrete features. So then now you have to tell that what is this phenomena. So there is a mountainous terrain, and then above that there is a plane is going, and then you can say that in which category you can put. So this is a mountainous these things. It is something giving elevation information everywhere. So there are no gaps in between that. So it is called a field phenomena, and then it is also continuous type of field, and then there is no gaps in between that. So you can tell about this. What is this? So it is more of a there are, as I mentioned, that buildings have a well-defined distinguishable entity, but if you see from the side look, it looks as if everything is filled up. But if you see from the top, so there will be certainly gaps in between that. So that means the objects are there on the ground, but they with a certain distinguishable feature and entity. But when you see in between this, that in between is there will be gaps. So then it is more of a object and then discrete feature. So it is a discontinuous basically. So it is object and then discrete field. So another thing you should also see. You should also think in this direction, and then note down this question. Name any two discrete phenomena which are natural. So what we talked is all the things, man-made things will be the discrete phenomena. But in this, what I am asking is, can you name any two discrete phenomena which are natural? So one is man-made, another is natural. Mainly all natural features are of a continuous phenomena. But here we are asking differently. Can we name any two discrete phenomena which are natural? So reversely, can you also name any two continuous phenomena which are of man-made? So just think of that, note down the question, and then maybe during interaction and get further clarify. And then if somebody says that this is man-made but it is a continuous, give a good examples, think of it. So later on we'll come back when question session starts. So far what we discussed is, we discussed about a geographical phenomena, we talk about object, and another is a field. Object is a discrete entity and field is a continuous entity. That is what we discussed so far. So fields can be a discrete or continuous. So when you talk about field, what we said is they are of a continuous. But here we are also talking discrete and are continuous also. In a continuous field, the underlying function is assumed to be continuous. So if you say continuous, you are talking about a particular information, a particular type of map. So it will have information, and then that information will be continuous, like a temperature, like a elevation. So these are all is a continuous. So this field, if there is a temperature is there, if it is even rainfall, and if it is a height information or a slope, this information, that is also continuous. This thing, changes in the field values are gradual. In this case, if the elevation is there 150 and then 150.32, so like that your height value changes, but that changes gradually. In case of a continuous field, we can determine a measure of change per unit of length anywhere. This measure would be a slope. See, if you go over the area, if the sloping is the sloping area or different terrain information, it changes slowly and then changes incrementally. So that means it changes value per unit of distance. If you take each pixel as a particular resolution, and then each pixel wise you will have a information like a temperature. Can be a temperature or a pressure value, height information. So then each will have some information and then changes with each change of the pixel value. And then as I said, discrete fields, if it is a field, it can be a continuous or a discrete. And then if it is a discrete field, divides the study spatially in mutually exclusive bounded parts with all location in one part having the same field value. It is something like you can think of it. So discrete, how you create a discrete field. So like when you talk about land use land cover map, as I said already, in case of a land use land cover map, we will give boundaries for each feature. If you talk about a soil map, or if you talk about land use land cover map, in that, suppose if you have a forested area, agriculture field is there, or urban commercial building areas, or residential areas, schooling areas, or a tourism area. So what we are doing is we are dividing the whole field into a different categories and putting a boundary for each category. So that means the field having a certain boundary. So these are all called discrete fields. So that means there is a value for each location. There are no empty spaces, but they are discrete because the land use land cover is changing abruptly. So there is a forest boundary. After that, immediately you have a agriculture field. So that means there is a change in attribute, a change in value from one bounded value to another bounded So that's why they are called a discrete fields. But they are continuous. Difference between a discrete field and object. So discrete field is again is a continuous field, but there are values changes with change of boundary values. So discrete field as well as object make use of the bounded features. So basically land use land cover putting the boundary. A discrete field can still assigns a value to every location. So that means land use land cover, if you go anywhere on that, there will be values there. In case of objects, there are space between objects are empty. When you say object, there are objects, but there are spaces in between, so they are all empty. Discrete fields where then you have boundaries between features, and then instead of in case of object, there will be an empty spaces between those things. See, you see these. There are two pictures here. One is a terrain with elevation changes. Another is a land use. So, in case of the terrain, basically what I said is elevation is it changes in a continuous manner, and then incremental is a step by step, and then you have a continuous elevation values with the incremental changes. But in case of land use here, if you put a boundary, so this is basically a discrete field, but there are boundaries in between. If you see this, there are agriculture field, and then in between there are a settlement area. One is a discrete field, another is a continuous field. Land use here is a discrete, elevation is a continuous field here. And now which phenomena is this? So it is also something like a land use. So it is also discrete field, because the color is changing with the boundaries. So that means if I move from one field to another field, suppose if I say Q to X, so then it is changing, sudden change from one type of field to another field. So as I mentioned earlier, we are talking about a field and objects. In case of fields, what we said is they can be a continuous, they can be discrete. Continuous means like elevation, and discrete means like a land use land cover map. And then in case of objects, objects also it comes under this field also it is a discrete, but objects also there are distinguished objects with a well-defined object, but there are spaces in between that. So you can also say field is continuous and discrete, whereas objects it is always discrete. That means there is a defined features and as well as that empty spaces in between them. So the examples are here. You can say temperature is a continuous field and a land use is a discrete field. So building features is a objects. So what we discussed is, we discussed about objects, and then objects are always discrete, whereas the fields they are discrete or a continuous. So these are two things. And then if you talk about geographic objects, object position in space is determined by a combination of one or more of the following parameters. So they have a certain location where they are located, and they will be having a certain shape, what form it is, and then they will also have a certain size, and there also will be there in which direction it is facing. So that means they have a location, shape, size, and then orientation. These features are there with that. And then if you talk about object representation, so dot is a 0 dimensional, and then if a line is there, straight line, that is a 1 dimensional, and then you have a 2 dimensional, there is a rectangular feature, and then if it is a 3 dimensional, you have a x, y and height information. Sizes also, if you see different sizes, and then orientation of those things, which direction they are there. So phenomena which have boundaries, they are called the discrete fields, and then objects. So in this also there are two different type of boundaries. One is crisp boundary is there, another is a fuzzy boundary. So crisp means, so with that there will be changing. If you talk about a land use land cover, we are putting a crisp boundary for that. And then there is a forest boundary is there, that for, and administrative, it is also administrative boundary, and it is also crisp boundary. And if you have a water body or a reservoir is there, that also will have a crisp boundary. But there will be also some features which are not a crisp, but they are also fuzzy boundaries. So that means you cannot draw a specific line. Suppose if you talk about this one, the colors of different algae, so there are things is very green here, and then there is something like here. It is a green and yellowish. It is difficult for you to put a what is that, crisp boundary. So if we ask these two people to put a boundary, people will put different boundaries because naturally they are also occurring. So somebody has put a boundary here, but if I give to somebody else, so you will also add some more area to this. So these are all fuzzy boundaries, means boundary is changing from one to another. See, if you talk about a built-up area, somebody asks you to draw a line, draw a boundary line. So somebody can see there are the pink color is there. So they think that these are the built-up area, and this is another building. There is another building. Somebody else is also put in a red boundary, combining all things together. So that means, so there are features are there which are they are not a crisp boundary, they are also fuzzy boundaries. So according to somebody make it more generalizing, so then it is also becoming a fuzzy boundaries. So somewhere if you wanted to put a field like this, and then there is a crisp boundary is there. But if it is buildings are also combined with the vegetation, if you don't want to separate those vegetation because the vegetative area is small, building area is more, so then you cannot put a crease boundary for that. So take an example, suppose if you have gone to seashore, there is a low tide, high tide also is there. So where you will put the boundary where the seawater is touching the land. So because this is basically is not a static water, it always moves, comes and goes. So during high tide zone time and low tide zone, otherwise also the boundary also is not constant. It moves up and down, so goes inside and come back. So this is the boundary where you will put. This is all fuzzy boundaries. Even when you make classification also in the these things, some features it is cluster clear that it belongs to certain feature. Some of the things it neither belongs to one category nor belongs to other. So it is a combination of that. Suppose if you talk about agriculture and which forested area, sometimes we cannot put boundary because the spectral variation is we will not be able to find out. So those things goes, either it goes to forest, some places it goes also goes to cropped area. So that is, those are the things goes into a fuzzy boundaries. So far we discussed about an object. So object in a discrete, having a certain location, shape, size, orientation, and then we have a boundary. Boundaries also we discussed. It is like a crisp boundary or a fuzzy boundary. And a field we also discussed about, it is a discrete or a continuous. So when it comes to computer representation, so objects we can represent in the form of a vector. It is a point, line and polygon feature. So this, as I mentioned yesterday, which is having some quantity and direction, that is called a vector. So and then on the ground whatever is feature is there, so that all features we can categorize into points, lines and polygons. So that way it has to be. And then field representation, suppose if you have some field information is there, one option is that you store everything what is coming. So another is option 2 is you take a sample, so and then put the representative, finite number of location with elevation, and then those points will be used for further interpolation and getting the spatial information. So one option is collecting points on the ground, but at the same time it is not possible to collect all the information. Though it is possible, but it is a very costly proposition, and then time also you have to. So that's why you have to decide how many points you want to collect, and then the method of collection. So all these things once you decide, so then the sampling becomes faster. So that's why then you decide on the points to be taken, and those points you can bring into the GIS, and then later on you can interpolate and then use it making the total spatial information. So then another option is you talk about what is there on the ground. Suppose if there is a water body is there, there is a vegetation is there, there may be the soil or forest is there. So what is there on the ground, and then how to bring it to the computer. So what you do is you can make a tessellation. Tessellation means square type of a mesh, and then you put it on the features, and then wherever that full square is covered, you assign a value. Suppose if this blue color is covered fully, so then you give an value. So another blue color is there, we give an value. So that means you are getting a 2 pixel elements here. So whereas here in case of a feature, it is an uneven shape, circular shape, but in case of the feature, what you get from the representation, it has become 2 squares. So that is the problem with a tessellated output. And then suppose if you talk about any feature here, so there is a forested features. So there is something also going into the feature, and then something also it is less than 1 pixel, but is more than 50%, normally we assign a value. So like that whole area is divided into different features. So this is called a tessellated output. You can also say this raster representation, how you do it. and then finally it will be stored in the computer like that. Phenomena is very important component in GIS. So it is basically what is that geographical phenomena? It is something like an instance and an activity process, that what we discussed in the last week, and then how to bring that geographical phenomena into GIS, and then when you bring that, in what way you should represent. So it can be a object, it can be a field, and then object also, it is basically what I said is object is a discrete object, and then distinct feature, having a distance feature, either that we can represent in terms of a point, line, and area, and then having a certain location, space, size, orientation, and then you represent that in terms of a vector object, or you can put it in a in different type of, in a raster also we can do that. So when we come to that field, we also mentioned about either it is a discrete field or a continuous field. So suppose the examples are given like a representation of a temperature, humidity, or a digital elevation model. All this comes under a this is a continuous field. Suppose if you talk about a land use, land cover map, then how to represent that in a computer, in a GIS, and then that it will having a discrete nature. That means the boundaries in between from one feature to another feature, it is changing. So it can be changing from agriculture to forestry, forestry to water body. So the feature is changing. In case of the continuous nature, there is a change, but minor change, but the value will be the same. So that value it will not change, like it will not change from one land use type to another land use type. So that is the difference in this case. And then how to represent in a computer. So if you talk about objects, so we represent in the form of a point, line, and polygon, that is in a vector data model. And then you can you can also represent in different raster format. So the raster format, it is called tessellations. The tessellation also, you can say that if you divide the whole area into equal square grids, so that is called a regular tessellation. It can be any other things also, uniform, regular, like hexagonal or triangle, etc. But we are not talking those things much, because normally we use in a square regular tessellation. Another is irregular tessellation. Irregular means it is not a size of each pixel or each cell is not the same. So that will be that it is the difference. So that's why they are called irregular tessellations. Now if you see this picture representation of the field, we have three different fields. One is the regular tessellation of the square grid. Another is a TIN, triangular irregular network. This will be further discussed as part of a data models, raster and vector data models. There it will be elaborated further. It is something like if you have a hilly terrain is there, and to represent that hilly terrain, this triangular irregular networks are used. This triangle, where are all the 3 points in the triangle, you have a known values, known height values, and then in between the values are interpolated, and then accordingly the values are assigned. So from the known 3 points, we are constructing a triangle for the whole area. So that's why if you zoom this image, so you will see that irregular triangles are constructed, and then the terrain is created. Another is you also can represent in type of vector representation. So what I mean vector representation is something like you have lines are there, each line having a each line is having the one value, similar value. Suppose if you say this is a contour, that line will be having the same contour. Similarly, next line. So it can be the incremental or decreasing nature. So these contours are represented. The same height information, what we are doing is we are representing to regular tessellation using a square grids. Another is the thin triangular irregular network. Third is you represent in the vector representation, and that is shown in terms of contours. So if you see, if you try to observe what is the difference between the vector and raster. Suppose if you see in this image, there is a digitized output here on the left side. If you see that square area, and then if you zoom that, whatever the lines are there on the original image, so they are extended again as the lines. So whatever zooming you do here, it will have the same line, because there is something like a you create two nodes and in between that you have a line. So whatever the you zoom it, there is not going to have any effect. It will still be having a thin line. But it is not the same case if you talk about a raster representation. In the raster representation, the lines also converted into regular grid size. So that means if it is 10 meter by 10 meter, so then we will have one cell for the 10 meter by 10 meter. But if you zoom it, so the cells which are there, so they are zoomed. So that what will happen is, so you will show as a thick this thing lines, and then the thickness also increases if you go on increasing the zooming level. So that's why you will see that in a stepped representation in case of the raster, but in case of the vector, that line will be again still line. So that's why if you wanted to have the more accuracy, so vector mode of representation is always the better. But it is not always possible to do only vector. For some type of studies, we still need to do in the raster. So what we discussed earlier is vector representation, point, line, and area. So later on, we also discussed about a triangular irregular network. So that is an additional whatever earlier we are telling is a point, line, and polygon representation. Tin is also in a vector representation. But here irregular triangles means triangles of different sizes are used to construct the whole area what you wanted to represent. So example is height information, what we do it. Another important thing is once you digitize and you create your layers, and then you also analyze and you combine your different type of layers together, and then finally bring it to a composite map. So then once you have that map, we should also show that in a visually impressive manner as per the cartographic principles, and then that thing, how do you represent it? Suppose if you talk about a representation of a features, so there are three things are there. One is a point, line, and area. How to represent in a point? Suppose if you wanted to quantify according to the size point information in terms of a quantity, like if you talk about whole state map, in that there are different districts are there, and then if you have different mandals are there, then if you want to represent the population density or the population capacity, then you can represent according to the population density. You can show is a smaller size or bigger size. So the district, and then in that you can also show it as a point. And then all suppose if you talk about a district, so each district you can represent the what is that circle, the bigger or smaller according to the population density in that particular district. So similarly, when you talk about lines, say suppose you talk about highways, so then in that highways, according to the type of highway, if it is a grand highway connecting to Delhi and Agra, 8-lane highway, or it is 6-lane highway, so then you can represent in a different thickness, and if it is a state highway, that can be shown in a different thickness. And similarly, it can be also the canal systems or drainage network according to the width or the water availability of water in that. So this line is represented according to something you wanted to represent, which will also give some meaningful information according to the thickness. So similarly, you can also show the same thing in terms of area. Earlier, I don't know how many of you, you may not be aware. So nowadays, what you get is a color printer, laser printers, like a black and white and color printers. Earlier, the printer, and then when you wanted to print a big maps, this whatever you take A4 size, that will not help. So you have to take A0 size. So there, earlier we used to do in a vector printers and raster printers. In a vector printer, there used to be a pen is used, and then using that pen, you can show it for a point, line, and area. So you can put some different pattern, so that suppose if you don't have a color output used to be very expensive. So the same thing in area, if you want to represent, different area feature can be shown in a different density wise, and then different grades of color, same color, and then otherwise different pattern. If you see this third one having a different pattern, fourth one also is having a different pattern, fifth one also is having a different pattern. So, and then there is also color. So same area you can show in a different way. So according to that practicality, like if you don't have a color printer, how you can show it in a different pattern. So that is what it is mentioned here. And then similarly, according to the size I mentioned and according to the value. So according to the economic or developmental conditions, so you can also show it in a value based. Suppose if you wanted to have a higher value is the maybe whitest is higher value, and then blackest is maybe the less value, but the size of dot is same here. So this color is basically what is that grade, what I say, grading of that one particular color. So that means lightest to the what is the darkest, you can give different value. Another is a grain size, what you say, how to represent in case of point and then line and then area it is. Similarly, if you wanted to represent in a different color for points, how it can be done, and then point, line, and for area. And then orientation wise, suppose if you wanted to show something like a slope and aspect, which direction the slope is there, probably this direction orientation may help you in making your area map and the line map and then your point map. Shapes, different shapes are there. It can be a square or a triangle or circle or a star. So like that you can give a different this representation. So it is basically how to prepare a map and how to use these symbols in that. So symbols and legend, that thing which comes into picture. So, and then I think at the end of this GIS, we are also having one lecture on the cartography and visualization. So there all these cartographic principles of map making will be discussed in detail. So as far as the geographical phenomena is concerned, this is the total representation. What is the geographical phenomena? It is an object form or a discrete having a certain location, shape, size, orientation, either it is a crisp or a fuzzy boundary. And then you have a field, you have a discrete versus continuous. And a computer representations, we have one is a vector, their point, line and area, polygon, and then we have a irregular tin shape. And then tessellations like a raster, which is a regular tessellation, and then we have irregular tessellations, and then how they are represented or visualized in a cartography in a map. We show in a color, size, value, orientation, shape, grain, and animation, etc. So this is the complete details about the geographical phenomena. So with this, I complete my lecture on this geographical phenomena.